Okay, today's lesson is 2.8, Graphing Linear and Absolute Value Inequalities. And remember, you've done this before, so I'm going to go through it a little bit quickly. The new part is at the end. Please email me if you have any kind of questions or need a Google Meet. Okay, so first off, remember that inequalities means the solution is a shaded region and the boundary line will be dotted or solid. So to make this, oh poo, hold on. To make this go a little bit faster, I'm going to talk about how to graph it and then show you the graphing so you don't have to get bogged down with mine not being able to graph on this electronic device. All right, so if we have graph 3x equals 3x plus 1/2 y is less than 2, okay? Most of y'all are going to solve for y to start off with to be able to graph it. So you're thinking about the fact that this would be an equation, an equal sign. And so the first thing I want to do is subtract 3x, get it to the other side. So I have 1/2 y is less than negative 3x plus 2. And then to get rid of my 1/2, I multiply everything by 2, which is going to give me y less than negative 6x plus 4. Remember, if you ever multiply or divide by a negative number, that you have to flip that inequality sign. So when you are graphing, okay, you are going to have a shaded region, but you have to decide whether the boundary line is going to be dotted or solid. And it all depends on that symbol right there. So since it is just a less than symbol, then it is going to be a dotted line. Okay. The other thing, I had envisioned teaching this live, so things are a little different when I set it up. But the other thing to point out is that our y-intercept, I know that y'all know, is 0, 4. And if y is on the left side and you have a whatever this symbol here is, this is a less than symbol, then when you shade it, that means that you're going to shade less than is going to be below your y-intercept. Now, you can always pick a point, 0, 0, as long as it's not on your line, plug it into the equation and see if it's true or false. If it's true, the point that you plug in is true, then you shade that region. If it's false, you don't shade that region. Okay, but this is a very easy way if you can get it straight. Y is on the left side by itself. You can follow the symbol. That says less than, so that means I'm going to go below the y-intercept. So when you look at my line, it's going to be dotted. I'm going to have my y-intercept of 0, 4. Of course, my slope is negative 6. And then I'm going to shade below the y-intercept. So that is what my graph looks like. I have my y-intercept of 0, 4, my slope of negative 6, down 6 over 1, down 6 over 1. We said the line would be dotted, and I found my y-intercept, and I shade below it. So below it means I'm on the left side of the line. So it's not always the left side, the right side, above or below. It really is all tied to that y-intercept. Okay, so look at our next one. We have graph negative x plus 2y is greater than 4. So again, I'm going to solve that for y. So I'm going to add x to both sides. 2y is greater than x plus 4. Then I'm going to divide by 2. So y equals 1/2 x plus 2. I'm looking at this to decide whether my line is going to be dotted or solid. Okay, it's not equal to, so that means it's going to be dotted. So the other thing that you want to pay attention to is that my y-intercept is 0, 2. And that says y is on the left by itself. This symbol is greater than. So that means I'm going to shade above my y-intercept. And I hope I haven't written on the graph. So this is what my graph looks like. So I have 0, 2. That's my y-intercept. My slope is up 1 over 2. You can see all the dots that I'm putting on my graph. I'm filling up my graph. It's a dotted line, and because it's a greater than symbol, y is on the left side, I'm going to shade above the y-intercept. So here's my y-intercept. Above it means clearly it's going to be above that line. Okay? All right, next example we have is a real-world example, and that says, Manuel has $15 to spend at the county fair. The fair costs $5 for admission, 75 cents for each ride ticket, and 25 cents for each game ticket. Write an inequality and draw a graph that represents the number of R ride and G game tickets that Manuel can buy. So first off, I am figuring out that I have $5 to actually get into the fair, and then I'm going to have 75 cents for each ride ticket, 25 cents for each game ticket, and that has to be less than $15. So I know y'all are really good at this. So my equation is going to be the mission plus the ride tickets plus the game tickets has to be less than or equal to $15. So there's my inequality, but to graph it, I need to simplify that. So for those of us who didn't grow up with calculators, we simplify it first by moving the decimal point over however many decimal places we need to get rid of the decimal. So in this case, I would move everything over 2 decimal places, which gives me that. And then I'm going to bring my 500 to the other side. And then I'm going to divide by 25 because I know 25 goes into every number. So I have this. Now, this is, we've talked about this, the standard form of a line. And if it is the standard form of a line, the easiest way to graph it is plug in 0 and then for each of the variables. Now, I write it like this, and what you have to decide, y'all, and it does not matter. You just need to decide which way you want to do it and be consistent. And for that reason, I'm going to write an ordered pair. And I need to write whether that's going to be GR or RG. It does not matter. But I write it down because then I can remember when I graph it. So this first one here, I'm plugging in 0 for R. And if I plug in 0 for R, then G is, of course, going to be 40. And on the next one, if I plug in 0 for G, that's what that is, then R is going to be 40 over 3, which is just a little bit more than 13. So you plot those 2 points, connect them with a solid line, and then I'm going to shade. Now, when it's in standard form, y'all, it's really easy for your test value to be 0, 0. So this is different from the one we had before where y was by itself. So if I plug in 0, 0, then that's going to be 0 and that's going to be 0. And is 0 less than or equal to 40? Yes, it is. And so that means I'm going to shade 0, 0 when I graph it. So this is what we get when we graph it. Move up just a little bit. Okay. One thing that's really important, I just labeled the axes, but it would help also to write down this, of course, is the number of ride tickets, and this is the number of game tickets. Okay. 0, 40, there's that intercept. And then 40 over 3 is a little bit past 13, 13 and 1/3. Then that is my intercept of my R. Okay. We talked about it being a solid line because it's equal to, and we talked about the fact that 0, 0 is going to be shaded, so we're shading this way. And the reason we limit it usually in real world problems, y'all, it doesn't make sense to have negative values for game tickets or ride tickets. And so that's why a lot of the real world problems are limited to just the first quadrant like that is. Okay, so those were linear ones. Let's talk about absolute value. Absolute value inequalities. Remember, absolute value looks like a V, okay? And so we have some changes to this graph, okay? You have a 2 and you have a 3. And the 3, I hope you know, that's outside the graph, so it affects the Y. That's shifting the graph up 3 units. There's nothing inside with the X, so it didn't get shifted left or right. This is shifting up or down. This will be shifting left to right. So my vertex is at 0, 3. This 2 is telling me the slope is going to be plus or minus 2. Okay? The next thing I have to figure out is whether my line is going to be solid or dotted. And it's equal to this time, so it's going to be solid. And then I just talked about y is by itself on the left. This is a less than symbol, so I'm going to shade below the y-intercept. And what you have to decide, On your y-intercept, you're looking at the graph, and that's either going to be inside or outside. So if my graph is going up, there's really no way to show it to you in parts, okay? But my vertex is at 0, 3. Okay, 0, 3 is the y-intercept, and I'm going below the y-intercept. So that's going to be outside of my absolute value. Here's my y-intercept, 0, 3. I went up 2 over 1 in both directions, and then again, up 2 over 1, and it looks like I didn't do that one very well. That should have been right here. That should be right there, guys. Bad. Up 2 over 1 should be right there. Okay, so, but more importantly, you are shading below your y-intercept. My y-intercept is here, so I'm shading below it, which is going to be outside the parabola. Okay, look at y is greater than or equal to 3 times the absolute value of x plus 1. Okay, that plus 1 is inside the parentheses. It affects the x and does the opposite of what it looks like. So you think you're going to add 1, but you're actually going to subtract 1, which means it moves it to the left, and my vertex is at negative 1, 0. That 3 in front is telling me the steepness, and that is plus or minus 3. Is my line going to be solid or dotted? I hope you said solid, because it's equal to. And if it's greater than, y is greater than, means I'm going to be above my y-intercept. Back over there was outside. So above my y-intercept, you don't know that y-intercept until you graph it, but you're going to see it's going to be inside, because this is my y-intercept right here. I started at the vertex, negative 1, 0, up 3 over 1, both sides. Up 3 over 1. Okay, so this is my y-intercept, and I have to go above it. And if I go above it, I am inside my v. So that's how you know whether to graph it. And you can always just pick a point, plug it in, and see what you do. Okay. All right, the next thing that we have to talk about is something that is called a piecewise defined function. And that is any function that is written using 2 or more expressions. Here's some examples. Graph each function, identify the domain and the range. So when you graph these, and I'm telling y'all now, they're all linear functions, all of these. So you're graphing parts of lines. Yes, in your future, will you graph something other than lines? Yes, you will. But right now, for this class right now, we're just going to do linear functions. Okay? So to start off with, I happen to think most important part about graphing is knowing the endpoints of these graphs. Okay, so that means I'm going to take negative 4 and I'm going to plug it into that function. So negative 4, if I take negative 4 and plug it in for x, well, there is no x because every point is negative 3. Every y value is negative 3. All right, I'm going to go to the next one and I'm going to plug in negative 4 and 2. And when I plug negative 4 into x, I get negative 4. When I plug 2 in for x, I get 2. Okay, and then I have this one, negative x plus 6 for x greater than or equal to 2. And so when I plug in 2 into this expression, negative 2 plus 6 is 4. So those points are going to be the endpoints of segments or rays on my graph. The other thing you have to pay attention to is if it's equal to, then this point will be filled in. If it's not equal to, these points will be an open circle, and this point here will be a closed circle. So I'm going to go ahead and graph it just to show you, okay? So I plotted all of those points first. So negative 4, 3, I color-coded it to try to help you see. Negative 4, 3 is down here, and then I look at this, and I say, that's a line. This says x is less than negative 4, so I have to go this way. If it's equal to a number, that's my constant function. So I'm at negative 3 and just graphing negative 3. Now, this middle piece, y'all, is the easiest because if you plot those 2 points, all you got to do is connect them. It's a line because I told you everything we're doing is lines. And then when you go to the last one, 2, 4, we plotted that point. And then I clearly left my arrow off or it got erased. Okay, but that should have an arrow on it because it goes on forever and ever. Now, keep in mind, y'all, that if you did this incorrectly, then you might have something that looks like this. Okay? And one of the reasons that you should know automatically that it's wrong is because it does not, when you graph it, this does not pass the vertical line test because you would be filling it in right, crossing it right there and right there. So that's an impossible situation. So just know when you're graphing it, it's kind of easy to check yourself and know which part of it you're going to graph. That was the whole line. If I were to graph y equals negative x plus 6, okay, clearly I can't do a good job there, but I only want it for x greater than 2. So if you think about where x is greater than 2, it's this part over here. That's why I only have this piece of the graph. So if you need any help, please come see me with these. Okay, we have to identify the domain and range. The domain, you can look at this piece, look at these right here. And if it says x is less than negative 4, and then it goes from negative 4 to 2, and then it picks back up at 2, it's basically covered all the numbers. Okay? So it is negative infinity to positive infinity. Now, the range is a little bit trickier. Easiest to look at your graph. You have an arrow going this way. You have a dot. Looks like that's the lowest point on your graph. However, this is a line, a ray, technically, that keeps on going. So the lowest point on my graph is actually negative infinity. But the highest point, it never goes above this number here because there's no arrow pointing that way. This arrow is pointing to the left, is not going up in any way, shape, or form. So the highest point on my graph is going to be 4. Does it include the number 4? It does because the dot is closed. Okay. Look at this next one. Remember, you want to plug in the points. We got f of x equal to 8 if x is less than or equal to negative 1. So I'm going to plug in negative 1. And when I do, y is always 8. The next one, I'm going to plug in negative 1 and 4. So I'm always finding the endpoints first. And if I plug in negative 1, I'm going to get negative 2. If I plug in 4, I'm going to get 8. And then negative 4 minus x if x is greater than 4. So I'm plugging in 4. Negative 4 minus 4 is negative 8. Okay? So you got to pay attention. Every time you go plot this, you go look back and say, is it open or closed? This one is going to be closed. When I plot this point, I'm looking here. It's going to be open. When I plot that point, I'm looking at that inequality. So it's going to be open. And then to take this one and plot it, it's going to be closed. Okay? So as much as I hate having to show it all to you at once, I'm going to go ahead and do it. So I went ahead and labeled this one by 2's because you weren't going to see much otherwise. So negative 1, 8. Okay? If it's by 2's, then I went left 1, up 8. Okay? And it's equal to 8. So it is a constant function. X is less than negative 1, so I'm graphing to the left. The middle piece is the easiest. Plot the 2 points, connect them. And then the last one, you have this point, okay? And one of the ways to remember is I can't go this way when I graph it. My slope of negative 1, because then it wouldn't pass the vertical line test, okay? So that is something to keep in mind and hopefully check yourself when you're doing these graphs. Okay, so that is, oh wait, I didn't do domain and range. Domain goes from negative 1 to 4, so it looks like we have everything. Negative infinity, positive infinity. The range, I have an arrow going down, so I've got negative infinity, but there is a gap here that is never equal to. So it's going to go from negative infinity to, I think that's negative 8. And it does equal negative 8 because it's a closed dot. And then I pick back up at this number, which is negative 2, but it's not equal to negative 2. So it'll be a parentheses. And then it goes only as high as 8. So negative 2 to 8, it is equal to 8. Okay? All right. So this time we were given the function and we had to graph it. Now we got to go backwards. Here is the piecewise function, and you need to write the equation. So we're trying to come up with something like this up here. Okay? So when you do these things, y'all, you want to, and I kind of color coded them if you can't see. This one is pink, this one is orange, and this one is, I think, purple. Okay? But what I get my people to do when they're doing this is to go ahead and write the beginning and write how many pieces you have to the function. So you'll know how many different ones you're going to have. So when I look at the pink one, which is right here, okay, that is our constant function, and it is just equal to what y value? 6. Now, it's 6 if x is, I gotta figure out what that number is. That number is -5. So it's going to be if x is less than or equal to -5 because it's closed in. Okay? On the next one, okay, this is the orange one, and I'm going to make it a little bit skinnier. All right. If you were to continue with this pattern here, y'all, then you could see that the next one is going to be right here. That's going to be its y-intercept. Its slope is, if they're both by 2's, then I went down to over 2, which is the same thing as -1. So I'm going to have negative x plus, and that y-intercept was 4, -1x, that was my slope, plus 4. And if x is between what two? They're both open, so I'm not going to have an equal sign, but that number is -5, and this number is -2. So it's going to be between the x values when x is between -5 and -2. And on the last one, I pick up here, and I would say this point here is halfway between 0 and 2, so that's 1. And my slope is I went up 1 box and over 2. So that slope is 1/2. So I'm going to have 1/2 x plus 1. If x is, now, is this greater than -2 or less than -2? Well, it's clearly greater than -2. So that is what you got. All right. I'm going to try another one because I think some people might want to hear it. So again, I have 3 pieces to my graph. So I'm going to start off by writing g of x equals and put 3 blanks. And I'm going to fill in each blank. And again, I tried to color code. So this is my pink one. Okay. And so y equals mx plus b, I can see the pattern. Okay. If I were to continue with this line, okay, I can easily see that my y-intercept is 4. Okay. So my slope is up 1 over 1. So that's just x plus 4. If x is, we're going to the left, y'all. So x would have to be less than -2. It is not equal to because that is an open circle. Okay, so this time my middle piece is a constant function. Those are the gimmies. And that number is -3. So I'm going to have -3 if x is between what two x values? Between -2 and 3. The dots are filled in, so it's going to be, both of them are going to be equals, less than or equal to. Okay, and the last piece, okay, it has a slope of, now this might not be so easy, because if I were to continue this line up, y'all, I would be off the graph. So that's not so easy to find. So I want to encourage you to, I actually picked this point here. I think I picked 4, 4, because you can see that it goes through, like, this does not go through 6, 0, but this does go through 4, 4. So I'm going to use that point, and I'm going to use the point slope form, because I can tell that the slope is, where is the next point? Oh, they did like that, didn't they? Down, 1, 2. It's pretty bad, but we're going to go with it. Slope is, what do we have? Oops, wrong one. My bad. So I'm going to have y minus 4 equals -2 times x minus 4. And when that's that point slope form that we just talked about earlier in the chapter. And if I distribute my -2, I'm going to have y minus 4 equals -2x plus 8. So I solve that for y, which means I'm adding 4. So that's going to give me negative 2x plus 12. And x is greater than, x is greater than 3. Not equal to because it's not filled in. Okay? All right, the last thing I got to talk to you about is a special kind of piecewise function, and that is called the step function. And a specific kind of step function, a special one that we talk about a lot in math, is something called the greatest integer function, and it looks like that. The books, y'all, because they have the ability to do it, write it like this, but you don't have to put the extra one in. So we just write it like that when we are not on a computer. Okay, so what is the greatest integer function? Most importantly, you need to remember its definition, okay? And so if you remember these words and say them to yourself if you ever can't remember, it is the greatest integer less than or equal to x. So if you were to make a table of values, okay, and you go, okay, what's the greatest integer less than or equal to negative 1? Well, that's negative 1. What's the greatest integer less than or equal to 0? Well, so if it's an integer, it's not a problem. But when you get into fractions, what's the greatest integer less than or equal to 1/2? Okay? Well, if you think of a number line, okay, 1/2 is between 0 and 1. So the greatest integer less than or equal to, if you're thinking about a number line, you always go to the left. So that's going to be 0. And what's the greatest integer less than or equal to negative 1/2? Is going to be negative 1. So when you have that, your graph is looking like this. Okay? And really what's most important for you to remember is that if you remember this first bar at 0, closed on the left, because remember our number line, we always point to the left. So it's closed on the left and open on the right, and then it just repeats. It has a slope of 1, so up 1 over 1 is how that works. But you need to remember, and whatever graph I give you, you're going to have to fill it up. So be prepared, okay? Now, I kind of want to talk about one last example of this, just so that you'll know how to tackle it in your homework. But if I were to give you something like this, g of x equals 2 times the greatest integer of x and plus 3. Well, y'all know that plus 3 would take this middle piece and move it up 3. 1, 2, 3. Move it to right here. Okay? That 2 is changing the slope. So if you were to go, it is, in essence, taking the graph, and you can think about it, act like that 3 is not there, and if you did the next one, you would end up multiplying it by 2. So it's kind of your slope, and it'll let you know that from this point, I don't go up 1, but I'm actually going to go up 2 to graph the next piece. Or I'm going to go down 2 to graph the next piece. Down 2, that's going to be open. So that's what that's looking like when you have a 2 in front of your integer. Okay? So I hope that helps. If you have any questions about your homework or doing those problems, please don't hesitate to email me. And I have no idea what just happened, but anyway, please don't hesitate to email me or come see me. Thank you so much, and y'all have a great day.